Yeah, g'day and welcome back to this, episode 3 of my bandsaw gearbox repair trilogy. As you can see, this project's reached that point known as maximum entropy. It's a natural point reached in any project where the mess expands to exceed all space available. Ever since I've owned this grinder, I have been kind of wondering whether I can do a cylindrical grind with it. It's a nice old Clarkson Mark I. When I bought it from my mate, it came with this pair of centers. So I just bodged up a bracket so that I can drive around part off this little AC motor. Hey, speaking of tool grinders, my mate Luke down in Malta has got this really nice D-Tech drill grinder. It uses these cams to set the back relief angles. He's got a few of the cams already, but he's not sure if he's got the complete set, and he's also a bit unsure whether there are any other accessories that might be helpful for this machine. So if anyone knows anything about these D-Tech drill grinders, please put a comment in the comment section and I'll get you in contact with Luke so you can help him out. Thanks a lot. Now, if you watched last week's video, you'd know that I'd had a shot at heat treating some of these parts, and I used a German process called Verschlimmbessern. That's a process which I would roughly translate into English as destruction through improvement. It looks like this main gear is still usable, but if we look at this input shaft, these bearing journals are supposed to be a light interference fit, and they've already shrunk, undersized. Now, I've tried every method I could think of to measure the run out, like doing it between centers here, doing it on V-blocks, measuring using the collets of the Schaublin, and unfortunately none of these methods was willing to lie and tell me what I wanted to hear. JC Wren was asking me last week why I put the two bearing surfaces on V-blocks to measure the run out here. These parts were turned between centers. I should still be able to mount it between centers to check that run out. The problem is, after the heat treatment, the whole thing bows. If you measure between centers, you're going to have like a gyrating center bearing. Because it's going to be mounted in bearings in the gearbox, you're really only interested in the concentricity of this plain bearing journal against these two journals. Let's just take a quick look at what did heat treatment do to this. It seems that the whole shaft has got some bit of bowing in it. So I couldn't just grind these bearing bushes between centers because then they would no longer be concentric to the gear. Although checking it in the Schaublin's collet, so this is the shaft that I didn't heat treat. So assuming this is a pretty concentric collet, now flipping it around, you can again see the good concentricity from Luke having machined it between centers. So how does the heat treated one compare? Now, this may well be the surface finish so bad that it's kicking the part off axis in the collet. Maybe we can improve that by turning it. It's way worse. Well, it doesn't seem to be related to the collet because there's no position where it even comes close to running true. What if I flip it around? It seems like these two are no longer even concentric to each other. Now, were those bearing journals still reasonably concentric, my plan was to use the Schaublin and hard turn this bearing surface concentric with them. I'd probably have to grind back 0.2 of a millimeter to get these to become round again, and then I'd be so far undersized that I couldn't even use a bearing adhesive. Honestly, I think I've ruined this one. I think the shaft is now going to be a wall ornament. Luke, I'm really sorry about that. I know you put a lot of work into this. Thank you very much for making two. I think I'm going to have to go with plan B and get this nitrided. But the good news is that Florian, Martin, Boris and Parfar reached out to me and recommended companies that can do plasma nitriding and that will work with hobbyists. Thanks very much guys, I've written to all of those companies, let's see how they answer, and I'll make up a new output shaft to match that set. So the project's on hold while I wait for parts. In the meantime, let's try out cylindrical grinding on the Clarkson. I'll just press in this bronze so I've got something to put a center into. I just whipped up this little bearing press. Okay, I'm going to say that's about centered. The correct thing to have done would have been leave a final machining allowance and then take it out to my mate's place and grind it on his cylindrical grinder. As JPM2651 said, this is the difference with hobbyists. We tend to want to try and do everything ourselves, whereas industry specializes. As we go further along the shaft, we get more run out. So it looks like there's some warpage probably in this area with the thinner neck maybe, but I'm going to have to grind that out. And since I've got a set of centers for the Clarkson, I think I'll bodge up just a little drive mechanism and see how it works as a cylindrical grinder. Being a British standard fastener machine, which has been in a metric country forever, you need pretty much every wrench that you've ever owned, or just use some adjustable. To spin the part, I've got this tiny little motor which came off a MK Unimat SL lathe. It doesn't take much power to spin a little shaft through an O-ring. Now I'm guessing that you want the grinding wheel on about center height. You can see on the gauge that each time I change direction, I get about a 1/10 of a millimeter movement of the table. This machine's got a fair bit of wear in it and the gibs were a bit loose, so I tightened them up. That seemed to improve things a little bit. I also failed to true up this wheel when I first mounted it, so it's not running very round. Right, well that surface finish is pretty bad. I do have the 60 grit wheel, which is a significantly bigger diameter, so let's try that. Maybe this higher surface speed will give me a slightly better surface finish. This is just a standard industrial diamond, about a 1/4 carat I guess, because as you know, diamonds are a grinder's best friend. Oops, forgot to turn on the vacuum cleaner on this first pass. Nope, that's still not round. Still a flat spot there. Ground finish with that wheel is definitely better. I still will need to give it a final polish up on the lathe, but that will have got it back to round again. cool, I get to use my homemade faceplate. There's a video on this somewhere, I'll leave a link. It's one of my first ever iron castings. I'll just use a stud to drive the dog. Right, now that it's round, can I improve the surface finish? This one is the plain bearing which the large gear is constantly running on. The gear change dog slides on this, but it doesn't rotate. Okay, well I think that's enough playing around with this. At a pinch, the Clarkson could be used as a cylindrical grinder, but you'd still have to polish the part on the lathe. Because I'd originally machined this part to tolerance, and then it shrank during heat treatment, and I had to grind some warp concentricity out, it's so far undersized. This is scrap. Well, there you have it. No real progress on the DoAll after all. Once I've found a heat treater who'll do the plasma nitriding and send those parts away and get them back, I can then get on with episode 4 of this trilogy. But until then, thanks a lot for watching.